We'll pan from left to right, seeing the strainer, the storage tank, the chilled water pumps, the glycol mini feeder, and the expansion tank. And next we'll see the front modules, 3 of the 5 mechanical cooling modules for the chiller. This view is at the rear end of the chiller, the leaving chilled water end. We're getting a close-up view of the hole in the lifting frame. This is one of several holes that will be used to connect the seismic isolators. In the next view, we'll pan down the front of the chiller, seeing a few more of the holes for connecting to the seismic isolators. It is important to note that the seismic isolators have 4 holes in the top, but there is only 1 connection point in the design. This matches the seismic engineering design performed by Mason Industries. As we pan down the rear of the chiller along the hot dip galvanized lifting frame, you'll see a series of holes. Again, each is a single fastener connection point to the seismic isolators. In this next view, you see the seismic isolator with the 4 holes in the top. Only one of those is used to connect to the chiller lifting frame. The holes in the base plate are used to connect to steel dunnage. This is a view showing the heat exchanger in the background of the storage tank. We've now panned around and are looking again at the heat exchanger, which decouples the building comfort cooling loop from the space being served by this chiller. These 2 panels are the C1 box on the left, which interfaces to this remote panel. The other panel was a control panel for the heat exchanger and control valves. Back looking down at the C1 panel, now panning to the heat exchanger control panel, and then back to the right, now on the back side of the auxiliary modules, showing the chilled water pumps, expansion tank, glycol mini feeder, and now the plate and frame heat exchanger and the storage tank. We'll now zoom into the chilled water pump section for the primary and backup chilled water pumps. We see the isolation valves and pressure gauges, now panning up to the bladder type expansion tank, and in the background, the 5-gallon glycol mini feeder. As we pan up past the check valves for the pump discharge, we come across the isolation valves, one in the foreground, one in the background, a temperature gauge for entering water into the chiller, and a pressure gauge for this common discharge point. We come down and the headers split into the entering header, which is the top header in a mechanical module. And then as we zoom down, we'll see the walkway going back to the rear modules. This view from the single point powered junction box shows the leaving water connection. Now we zoom down past the individual modules and the 432 amp door interlock disconnect switch and circuit breaker. Note this chiller is 380 volts 60 hertz, which is relatively special. As we zoom into the header piping that connects the front and rear modules, you'll see that there are isolation valves so that we can isolate the front modules from the rear modules. Now we zoom over to see the chilled water leaving connection, which has gauge taps as well as a leaving water temperature sensor tap. And now we'll get some close-ups of the pump module. First, the ports on the discharge of the pumps. You can see the 2 suction ports, the isolation valves, another view here of the suction pressure tap ports. This hard pipe is coming from the expansion tank. We'll show you where the glycol mini feeder ties in there at the top. That T at the top is where the glycol mini feeder's braided hose ties in. And we follow down the hard pipe into the suction side at the common piping that comes from the bottom of the storage tank. The braided hose there in that sensor location is one input for our DPs, which provide proof of flow. There are the 2 DP switches. We have 2 for redundancy. We'll pan back here and see the T so that we have 1 sensor location, but it T's into 2. DPs will pan up so you can see the discharge side of that differential pressure tap right there. And then this is back on the front side of the chiller showing those DPs and where they enter the pump control panel. This chiller was also provided with a power factor correction capacitor bank. We utilized ABB to provide the power factor correction capacitors. This module will be separate from the chiller and provided by Multistack for installation by the contractor in the electrical distribution system. The power factor correction capacitors will improve the chiller's power factor to overall improve the building's power factor. This is a view of the front of the power factor correction capacitor bank. We'll pan inside. At the bottom of the cabinet are the actual capacitors, and then as we pan up, we'll see the contactors that pull in the various banks of capacitors.